Welcome back. Today we'll carry on discussing propositional logic. This time we'll take a look at some applications, some of them a bit fun, as well as equivalences. So we'll start with a bit of fun. We'll look at some applications, and this is my favorite realm of logic puzzles. So this is one fun way to practice logical reasoning, and that's to practice solving logic puzzles. In order to solve them successfully, you need to engage in valid logical arguments. Let's take a look. In the following example, where is the treasure? There's only one treasure, and only one of the labels on these trunks is true. Trunk 1 states, this trunk is empty. The label on trunk 2 also states, this trunk is empty. And finally, the label on trunk 3 says that the treasure is in trunk 2. Before you proceed, hit pause and think about where the treasure should be. Then follow along and see if you were correct. Let's say we want to represent propositions as T sub I, where T sub I means that the treasure is in trunk I. We see a recreation of what was stated. Trunk 1, this trunk is empty. Trunk 2, this trunk is empty. And trunk 3's label states the treasure is in trunk 2. If we represent those propositions as T sub I, implying that the treasure is in trunk I, then T1 means that the treasure is in trunk 1, T2, the treasure is in trunk 2, etc. So let's see if we can represent what's stated on the trunk's labels in this format. Well, trunk 1's label states that if it's true, then this label states that T1 is not true. The treasure is not in trunk 1. And so it's the negation of T sub 1. If it's false, what that means is it is in trunk 1. If the opposite of this trunk is empty is that this trunk has the treasure. There's only one treasure. It's in one of the trunks. If that trunk is not empty, it's in trunk 1. Trunk 2's label is roughly the same. The label as stated, if it's true, is saying that there is no treasure in trunk 2. This trunk is empty. And so that's the negation of T2. If that label is false, then we know that it is, in fact, in trunk 2. Let's take a look at trunk 3 because this is the one that's a bit different. So trunk 3 states that the treasure is in trunk 2. So if that label's true, then what it's stating is T2. It's proposing that the treasure is in trunk 2. If that label's false, the opposite of that is it's not in trunk 2. We remind ourselves that only one of these labels is true and there's only one treasure. So we can take a look at the possibilities that trunk 1's label is true and the others are false. Trunk 2's label is true and the others are false. Or trunk 3's label is true and the others are false. Those are the only combinations. So first let's consider what happens if trunk 1 is true. Then we're reaching the situation where trunk 1 label is true, the negation of T1, it's not in trunk 1, and all the other labels are false. So then we're falling into this situation, T2 and the negation of T2. For now, we're not going to discuss what's happening with that. We'll just capture what would be the case for each of these situations. So let's look at what happens if trunk 2 is true. Well, if trunk 2 is the only label that's true, then we fall into these situations. The label on trunk 1 is false. The label on trunk 2 we're supposing is true. And the label on trunk 3 is false. And so we have T1 and the negation of T2. It's not in trunk 2 and it's not in trunk 2. Okay. So we see that's repeated. We can disregard the second one. But for now, we're going to leave it, as I said, as such, and come back to what all of this means together. Let's just capture what the possibilities are. Then finally, we have to consider if only trunk 3 is true. If that's the case, then trunk 1's label is false, trunk 2's label is false, and trunk 3's label is true. And so as stated, that means we've got T1 and T2 and T2. All right. And again, we see there's repetition. T2 and T2, it's the same as just saying it's in trunk 2. All right. So now let's take a closer look at them, because what we know is one of these is the case. One of the labels is true and the others are false. So we're either in situation A, B, or C. Which combo actually works? One of these is taking place, but which is the one that will guide us to an answer? Is it more than one? Well, let's take a look at the first one. What we see is we have this situation, T2 and not T2. The treasure is in trunk 2 and the treasure is not in trunk 2. This is a problem because this can't happen, right? It can't be both in the trunk 2 and not in trunk 2. In fact, this then tells us that this whole thing doesn't work. We can't resolve this. So trunk 1's label is clearly not telling us the truth. Trunk 1's label must be false. Let's take a look at the last example. Let's assume that trunk 3 is the only trunks with a label that's telling the truth. If that's the case, we see that it is both in trunk 1 and in trunk 2. We're not even dealing with the fact that there's a repetition of trunk 2, which we can ignore. Because can the treasure be in both trunk 1 and trunk 2 at the same time? It can't. And so this doesn't work. And so trunk 3 must not be telling the truth. And so now we know we're in this situation where trunk 2's label is the one we must consider. But does that even work on its own? Let's consider finally that possibility. And what we see is what's stated in this compound proposition is T1 and the negation of T2 and the negation of T2. Well, that says the treasure is in trunk 1 and the treasure is not in trunk 2 and the treasure is not in trunk 2. So these work together just fine. And the only possible solution is that the treasure is in trunk 1. So that's the one that we want to open. Let's take a look at another logic puzzle. And this is a common series of logic puzzles that you might enjoy. And it's built around this idea of an island of knights and knaves. And on the island of knights and knaves, there are two very different sets of inhabitants. Knights, who always tell the truth, and knaves, who always lie. We're going to use logical reasoning to determine who A and B really are based upon their statements. So first, we'll take a look at the following. A states, B is a knight. B states, the two of us are of opposite type. Take a moment and try to figure out what you think A and B really are, knights or knaves. Okay, so let's take a look at the possibilities of what could be happening. Well, we'll consider A. A is either a knight or a knave. Let's assume at first that A is a knight, and that means that what he's saying is truthful. B is a knight. If that's true, then what B said must also be true. B said the two of us are of opposite type. This is a problem. If that's the case, then what A said can't possibly be true, because if B is a knight, then A must be a knave, because the two of us are of opposite type must be true. But this would have to have been a lie. So B cannot be a knight, which means A could not be speaking truthfully by saying B is. So this leaves us with the alternate option that A is a knave. He always lies. A said B is a knight, but he's lying. If he's a knave, he must be lying because knaves always lie. So if the opposite must be true, then B is a knave because A was lying. Let's see if what B said holds. B said the two of us are of opposite type. But if B is a knave, then that isn't true. They're of the same type. And this is okay, because if B is a knave, this would have been a lie, and so A and B are both knaves works. They're of the same type, and so A and B are both knaves.